Hello students, welcome back. Today we are going to discuss about the very important concepts in differentiation, that is the solution of higher order differential equations with constant coefficients. Okay, so this is a very important concept. Solution of higher order differential equations with constant coefficients. Solution of higher order differential equations with constant coefficients. So, first thing, I will just write one simple general form of the differential equation. Let it be in this form: d power n y by dx power n plus a1 into d power n minus 1 y by dx power n minus 1 plus a2 d power n minus 2 y by dx power n minus 2 etc. equal to, let it be 0. Okay. So this is a simple differential equation. Okay, if it is some students, they may feel it is also difficult. Let me take one simple example. Second order equation like this: d square y by dx square plus 3 into dy by dx plus 2y equal to 0. Now you see here, everywhere y is there, right? So if I take y common, so it becomes what? D square y by dx square plus 3 into d by dx plus 2 into y equal to 0. Now you see, this whole term is what associated with y. Okay, so if I generalize this term, or if I write in the standard form, it looks like this. Thus f of d, here what d indicates is nothing but derivative with respect to x, d by dx. If it is, then d square y by dx square, it will go on. Okay, so now if I convert the second order differential equation to this form, then if I replace this by d, then it will be in this form. And this type of equations, what we call it as homogeneous differential equations. Homogeneous differential equation. What is homogeneous differential equation? In simple form, in any differential equation, if all the terms are associated with y, you see every term is multiplied with y or its derivatives. Okay. No free term is present in this equation. Such equations are called homogeneous differential equation. Now, if any differential equation which contains a term which is free from y and its derivatives, y is also called function. Function and its derivatives, that will be recorded as non-homogeneous differential equation. Let me take one simple example: y double dash plus 3y dash plus 8y equal to some sin x. Now if I take this y common, this becomes what? Let it be like this. It is in the form f of t into y equal to what? Sin x. Now you see, all these terms are associated with what? Y, and the sin x is free from this y. And such differential equations are called non-homogeneous differential equations. Non-homogeneous differential equation. And the solution of homogeneous differential equation is always simple. Okay? But the non-homogeneous differential equation is little lengthy. So this contains two types of solution. One is complementary function, other one is particular integral. So if we write together complementary function as well as particular integral, then that will be the solution of non-homogeneous differential equation. Then that will call it a general solution also. When it comes to homogeneous differential equation, complementary function itself is the general solution. Okay. So Now how to find out this complementary function, everything will, I hope it is clear. Homogeneous differential equation means what? Homogeneous differential equation means if f of b into y equal to 0, or let me take phi of x. Okay, if the right hand side means phi of x is equal to 0, then it is called homogeneous differential equation. It is called homogeneous differential equation. And if this phi of x is not equal to 0, let it be any function of x, that may be exponential, logarithmic, sine or cos, whatever it may be. Such functions are called, then it is called non-homogeneous differential equations. Non-homogeneous differential equations. Okay, hope it is clear. Homogeneous and non-homogeneous, very simple. Then the solution of non-homogeneous differential equation, the solution becomes, okay, so it is y equal to yc itself. So this yc is called complementary function. Yc is called complementary function. I'll tell how to find out complementary function. Then the solution of this non-homogeneous equation is nothing but it is the combination of yc plus yp, or sum of yc plus yp. So what is yc here? Complementary function, and yp means it is particular integral. So there are ways to find out complementary function and particular integral. We'll go one by one. Okay, since it's the introduction class, I'm just briefly explaining this. Now, how to find out complementary function for a homogeneous differential equation? Okay, so I am just taking one random example, general example, so that you can understand it properly. Let me take one simple fourth order. See, the heading is what? Solution of higher order differential equation with constant coefficients, right? So I will take, see, maximum in the most of the exams they may consider fourth derivative. I mean, fourth order differential equation for an average engineering students. Means apart from that, it is, as of my knowledge, you will not have in the book or a question paper. Okay, so only when you go for higher engineering mathematics textbooks, there you may get higher order differential equation. So for engineering students, maximum fourth order will be asked. So let me take that fourth order only. I am just taking one fourth order differential equation, y triple dash plus y double dash plus y dash plus y equal to 0. Here y, this means d power 4 by dx power 4 plus dq y by dx cube plus d square y by dx square plus dy by dx plus y equal to 0. Now everywhere we will take d means d by dx, d square means d square by dx square, etc. Now if I replace this here, it becomes what? D power 4 into y, d cube into y, d square into y, d into y plus y equal to 0. Now if I solve this, d power 4, d cube, d square plus d plus 1 into y equal to 0. See, this is how to write the given differential equation, whether maybe this form or this form. This into the standard form, means capital T form. After that, we are finding for this auxiliary equation. A means auxiliary equation. So, if we replace all the d values by m, that will give auxiliary equation. I am just taking m power 4, m cube plus m square plus m plus 1 equal to 0. Now you see, it is a fourth order differential equation. M power 4 is the highest order. Therefore, if we solve this equation, we will have 4 m values. Okay, let me take generally m1, m2, m3, m4. m1, m2, m3, m4. Now, depends on this m value, we are writing the different types of complementary function. Okay, so if the m values are real values, then we have one complementary function. If the m values are complex value, then we have one complementary function. Let me take all the cases one by one. Now, I'll just take one by one all the cases. So I'm just taking this example only and considering fourth order, and I'm having, let me take 4 roots here. M equal to m1 comma m2 comma m3 comma m4. Okay, 4 roots I have. So first case, what is the possibility? Case 1, if all the roots are real and distinct. If all the roots are real and distinct. That is, what is the meaning of real and distinct? All the roots are real roots and all the roots are distinct. Distinct meaning is what? If m1 is not equal to m2, m2 is not equal to m3, m3 is not equal to m4. All are distinct roots, different roots. Then when we have such roots, then we are writing complementary function as, let it be yc. So yc has some textbook that writes cf also, both are same, cf and yc. c1 e power m1x, c2 e power m2x, c3 e power m3x plus c4 e power m4x. Okay, this is how to write complementary function when we have real and distinct roots. c1 e power m1x, c2 e power m2x, c3 e power m3x, c4 e power m4x. This is first case. In the case 2, if all the roots are real, and may be repeated. If some roots are repeated, if all the roots may be repeated. Okay, let me take one simple instance. If I'll just take that is if m1 and m2 are same, let me take m3 also same, but m4 is the only different root. All the first 3 roots are same roots, but m4 is the different root. Then how to write the complementary function for this? Then complementary function will give, for all the 3 repeated roots, you have to write like this. c1, if one root is repeated, then it becomes x into c2. If 2 roots are repeated like m1 and m2, then it becomes x square c3 e power m into x, because the m is the same for all 3, because all 3 are repeated and real roots. If m4 also same, then it comes x cube c4 into e power mx. See here I am taking only 3 real and repeated roots. I have written like this, and the last one is distinct root, that will be written as c4 e power m4 into x. Okay, so if only 2 roots are repeated, only this much will come, and for m3 again we are supposed to write like this, c3 e power m3x plus c4 e power m4x. Okay, so if how many roots are repeated, that many times you have to write like this. This is the case when we have real and repeated roots. Then we may have sometimes complex roots. Case 3. If all the roots are complex roots. If all the roots are complex roots. What is the meaning of complex? Let it be, let first root will be alpha 1 plus or minus I beta 1 and m equal to alpha 2 plus or minus I beta 2. Because see, there are 4 roots here. Because m power 4 means 4 roots, m cube means 3 roots, m square means 2 roots. So m power 4 means 4 roots. plus or minus is there, alpha plus I beta 1 root, alpha minus I beta 1 root. Since they are complex roots, so they are always conjugate each other. That is the reason we have written like this. So whenever if the complex roots are comes and both are different roots, distinct complex roots, then how to write the complementary function? Y equal to or yc equal to e power alpha 1 into x. For this I am writing e power alpha 1 into x, a cos beta 1 into x plus b sin beta 1 into x. So this complementary function only for this first root, complex root, okay, plus second complex root means this is 2 roots, these are totally 4 roots, but since they are complex roots, they are conjugate each other, that's the reason I have written separately. For this again, e power alpha 2x, then a I use here, I will take c cos beta 2x plus b sin beta 2x. Okay, so this is how to write whenever we have distinct complex roots for any differential equation. Complementary function e power alpha 1x, a cos beta 1x plus b sin beta 1x. Here alpha beta are the real and imaginary parts of the complex number. Don't write anywhere I in the solution. Okay, so we are writing only real and imaginary parts of the solution. Alpha is the real part, beta is the imaginary part. Similarly, this other complex root we are writing like this. Okay. Now we may have one more possible condition, that is, just erase this all. That is the fourth case and the last case in this part, that is case 4. What is that case? If all the roots are complex and repeated roots. They are complex but repeated roots. What is the meaning? M equal to alpha plus or minus I beta is repeated twice. Alpha plus or minus I beta. Complex root but repeated roots. Whenever we have roots like this, then how to write the complementary function? Complementary function will be e power alpha x. Okay, e power alpha x, a plus x into beta, a plus x into beta cos beta x plus c plus x into d sin beta x. Okay, this is whenever we have repeated complex root, this is how to write the complementary function. E power alpha x, a plus x into beta into cos beta x plus c plus, it is not beta, it is b, sorry, a plus x into b cos beta x plus c plus xd into sin beta x. So these are the 4 possible cases to write the complementary function for any homogeneous differential equation with constant coefficient. So based on this, we'll solve a few problems, okay, so that you can easily understand it properly. Let me take one simple example. Homogeneous. Now we are dealing with homogeneous. So in the next session, I'll take the non-homogeneous differential equation and the solution. Now I will take a simple example. Solve dq by y dx cube plus 4 into d square by dx square plus dy by dx minus 6y equal to 0. Now clearly see all the terms contains what? Y. Every term y or its derivatives are there. Therefore, it is a homogeneous differential equation. For homogeneous differential equation, general solution is what? Yc. Yc we have to find out. That is the general solution. So first we have to write this in the standard form. That is why no capital D means d by dx. Okay, so everywhere we are supposed to remember it is d by dx. D square means d square by dx square, etc. If any term t comes there, then we are supposed to d by dt. Now it is understood it is function of x. Y is function of x. So this can be written as dq plus 4d square plus d minus x into y equal to 0. So this is how to express the given differential equation into the standard form, means f of t into y form. After this, you are supposed to write auxiliary equation. Auxiliary equation means all the coefficient of y term is there, no? That d should be replaced with m. So what happens it is m cube plus 4m square plus m minus 6 equal to 0. It is a cubic equation. If you use your scientific calculator, you can easily solve this equation in fraction of second. You will have all the m roots. All the values of m. Or else, if we wanted to do manually, if it is factorizable, we have to factorize. Or else, we have to use synthetic division method. I will take one example later. Once we have to find out one real root by trial method. Then we have to take synthetic division method to find out the remaining two roots. Okay. So now, if I use calculator, then I will have the roots called minus 2, 1. Okay, in scientific calculator, you can easily solve cubic equation. Now you see all the roots are what? Real and distinct roots. Whenever we have real and distinct roots, then we know how to write the complementary function. That is c1 e power m1. m1 is minus 3 here, minus 3x. c2 e power m2. m2 is what? Minus 2x. Plus c3 e power m3. m3 is 1 into x. That's it. c1 e power m1x, c2 e power m2x, plus c3 e power m3x. This is the general solution of the given differential equation. It is very simple. Okay, homogeneous solution is always very simple. Only the task is whenever you have m power 4 or m cube, if you don't have scientific calculator, you should know how to solve it manually. Okay, so that I will take later one example and I will show you how to solve it manually. Okay, so I hope this you understood properly. And I will move on to one more example. I will take. Solve d power 4y by dx power 4 minus 5 d cube y by dx cube plus 5 d square y by dx square plus 5 dy by dx minus 6y equal to 0. See, when you look the problem, it is very lengthy but it looks complicated, but it is very simple. Okay, very simple problem. You see here, every term y or x derivative is there. No term free from y. So clearly it is a homogeneous differential equation. For homogeneous differential equation, what is the general solution? Complementary function. That is yc. So to find out complementary function, what we have to do? We have to write the auxiliary equation. So to write auxiliary equation, first I will write this in the standard form. D power 4 minus 5d cube plus 5d square plus 5d minus 6 into y equal to 0. Now I have to write the auxiliary equation. Auxiliary equation becomes m power 4 minus 5 m cube plus 5 m square plus 5 m minus 6 equal to 0. So if we solve this, then we will have 4 roots. That 4 roots we have to write. M equal to minus 1, comma 2, comma 3. Here I am writing everything, since it is introduction class. I am just explaining how to write the general solution. So then in the next session I'll explain you how to find out the fourth root, cube root by manually. Okay. So after solving this minus 1, 1, 2, 3, we are getting again all the roots are what? Real and distinct roots. Therefore, y equal to c1 e power minus 1 into x minus x, c2 e power x, c3 e power 2x plus c4 e power 3x. This is how to find out general solution for a homogeneous differential equation. Hope it is clear. Okay. So in the next class, I will take a few more examples. Then I will do it manually also. How to find out this fourth root, cube root, square root, and how to use calculator also. I will explain. Okay. For this session, please study properly. What are the four different types of complementary function for homogeneous function, and what is homogeneous function, and the solution of homogeneous function is complementary function. How to write the complementary function, everything you have to study and be ready for the next session. Okay, so until that you just go through everything properly. So thank you all.